Hi students, now we are going to solve problem number 9. A cell supplies a current of 0.9 ampere through a 2 ohm resistor and a current of 0.3 ampere through a 7 ohm resistor. Calculate the internal resistance of the cell. Now you can see the first circuit. There is a cell of EMF E volt and its internal resistance is small r. You have to find small r, which is the internal resistance of this cell. Then the external resistance connected in the first circuit is 2 ohm. So in the first circuit, when 2 ohm resistor is connected, what current is drawn from the cell? It is I1 ampere. That I1 ampere is what? 0.9 ampere. Okay. In the second circuit, we have replaced this R1 by R2. R2 equal to 7 ohm is the external resistance in the second circuit. But the cell is the same. Its EMF is the same and its internal resistance small r is also the same. So when the second resistor of 7 ohm is connected in the circuit, how much current is drawn from the cell is I2 ampere. That is equal to 0.3 ampere. Okay. Now we will analyze each circuit separately and we will get two equations. Now in the first circuit, the total resistance in the closed path, the total resistance is R1 plus small r. Okay. Therefore, the expression for current I1 is equal to EMF E divided by the total resistance R1 plus small r. Okay. Or the same equation E is equal to I1 into R1 plus small r. I have substituted, okay. I have taken this factor to the left hand side. So I1 into R1 plus small r. Similarly, in this second circuit, the current is I2. So here I2 is equal to EMF E divided by this external resistance R2 plus small r internal resistance. So similar equation if I write means I will take this denominator to the left hand side. So EMF E is now equal to I2 into R2 plus small r. Since the EMF of the cell in both the cases is the same, I can equate the right hand sides of the two equations. Is it not? Equate the right hand sides of the two equations. So I1 into R1 plus R is equal to I2 into R2 plus R. Now open the brackets, okay? Open the brackets. First term is I1 capital R1 plus I1 into small r. So this is equal to I2 into capital R2 plus I2 into small r. Now we want to get the value of small r, is it not? So all the small r terms I will group on the left hand side. So already there is I1 into small r on the left hand side. So I1 into r minus this I2 r is taken to the left side. So it becomes minus I2 into small r. Right hand side there is I2 R2, is it not? So this is I2 into R2 minus I1 R1. So minus I1 into R1. So here small r is the common factor. So small r is taken out into I1 minus I2. So this is equal to I2 into R2 minus I1 into R1 divided by I1 minus I2. So R, therefore small r is equal to, okay, I have taken already, is it not? So this is next step, okay. Next step I will take this to the right hand side. So this is I2 into R2, okay, I2 into R2 minus I1 into R1 divided by, so this can be taken to the denominator here. So this is I1 minus I2. Now we are going to substitute the values for I1, I2, R1 and R2. So look at this circuit, this is 0.9, I1 is 0.9 ampere. So the first term is I2 into R2. So what is I2 is 0.3 I will take. So this is 0.3 into R2. R2 is 7 ohm. So into 7 minus of I1. I1 is 0.9 and R1 is 2. So this is 0.9 into 2 whole divided by I1 minus I2. So 0.9 minus 0.3. So this is 0.9 minus 0.3. Okay. So the product of 7 into 3 is 21. So 7 into 0.3 must be 2.1. So this is numerator. First term is 2.1. 2.1 minus 9 2s are 18. So 0.9 into 2 must be 1.8. So this is a minus of 1.8 divided by 0.9 minus 0.6. 0.3 is 0.6. So this is a 0.6. Okay. So now I will multiply on both sides by 10. This will become 21 minus 18 divided by 6. So 21 minus 8 is 3. So this can be written as 3 by 6 and that is equal to 1 by 2. So left hand side is R. Therefore the internal resistance of the cell small r is equal to 0.5 ohm. This is the answer. So we have determined the internal resistance of the cell small r is equal to 0.5 ohm. Have you understood? Okay. Problem number 11 in the exercise. A potentiometer wire has a length of 4 meter and resistance of 20 ohm. It is connected in series with a resistance of 2980 ohm and a cell of EMF 4 volt. Calculate the potential gradient along the wire. So we have studied in the theory the potentiometer is having 10 meter length of the wire. Here 4 meter they have given, that is the only difference. Now the potentiometer wire usually is made up of manganese wire, we have studied in the theory. Anyhow, it will also have some resistance per unit length and resistance for the entire length. So the resistance of the potentiometer wire is 20 ohm. But in series to this wire, an external resistance of 2980 ohm is also connected. Since it is connected in series, the total resistance in that potentiometer circuit will be this 2980 plus 200 ohm. And a cell of EMF 4 volt is connected. Is it not? So I will write the given quantities. So what are all the given quantities? So first one is potentiometer length. Okay. So length of the wire. Length of potentiometer wire is equal to 4 meter and resistance. Okay. So resistance, this can be taken as a symbol small l. Now resistance of the potentiometer wire. Resistance of the potentiometer wire is equal to 20 ohm. This can be taken as the symbol small r. And external resistor, okay, external resistance connected in the circuit. So external resistance is equal to capital R, that is equal to 2980 ohm. And the EMF of the cell, okay, EMF of the cell connected to the potentiometer. So EMF of the cell is equal to E, that is equal to 4 volt. Now from this first, what is the current sent by the cell? The current supplied by the cell. So current flowing through the potentiometer wire. Current through the wire. Current through the potentiometer wire. This is taking the symbol capital I. So this is equal to the EMF divided by the total resistance R plus small r. So the EMF is 4 volt. So 4 divided by the total resistance is 2980 plus 20. So this is 2980 plus 20. So this is equal to 4 divided by 3000 ampere. Now you can divide 4 by 1000. again divide by 3 you can do, but let us keep this as it is because it may get cancelled in the further steps. So the current flowing through the potentiometer wire. What is the resistance of the potentiometer wire? Already given. The resistance of the potentiometer wire is 20 ohm, is it not? That is the resistance. So what is the IR product across the potentiometer? That is called the potential drop. Okay. So the potential drop across the wire, across the potentiometer wire is given by V is equal to I into small r. So instead of I am going to substitute 4 divided by 3000. So this is 4 divided by 3000 into what is the resistance of the potentiometer wire. So 4 into small r. Small r is equal to 20, is it not? So this is equal to 20 into 20. So the 0 and 0 get cancelled. So this will become 8 divided by 300. So 4 2s are 8 divided by 300 volt is the unit. This is the potential drop across the entire 4 meter wire. So if you divide this potential difference across the wire by the total length of the wire. So total length of the wire L is equal to 4 meter. Therefore, what is the potential gradient we can find out? So the potential gradient is, okay, potential gradient is V by L. Potential drop divided by the length of the wire. So this is equal to V by L. So this is 8 divided by 300 into length is 4 meter, 1 by 4. So that this 4 and 8 get cancelled 2 times. So that this is equal to 2 divided by 300. 2 divided by 300. So this can be written as what? 2 by 3. 2 divided by 3 into 10 power minus 2. 1 by 100 is 10 power minus 2. Now 2 by 3 means 0.6 will be recurring, is it not? So this is equal to 0.66 or 666 also we can take into 10 to the power of minus 2. So this is therefore V by L is equal to 0.66 is recurring. So into 10 to the power of minus 2 volt per meter is the unit. Potential difference is in volt, length is in meter. So volt per meter is the unit for potential gradient. Okay, fine.